Thank you for joining me. Welcome to TJ's Maths Clinic. Still on differential calculus, we are looking at differentiation from first principle. With us here is example 2. Let's consider this example 2. The question reads, find from first principle the derivative of 2x squared minus x with respect to x. Let's consider this question. Let's write down the solution. The first thing for us to do, let's define this expression to be y. It means let y be equals to 2x squared minus x. The first thing for us to do, let's find increase in this y will be y plus, let me take it further, that will be y plus change in y will now be equals to, we have the constant 2, let's factor it out. We open bracket, we have x, increase in this x will be x plus delta x, because of this square, all square, minus increase in this x here will be x plus delta x. Very important. Okay, from here, we can say let this be maybe equation 1. Yes, let this be equation 1. Then let's work on this to get equation 2. Changing y now will now be equals to 2 into x plus changing x all square minus x plus delta x to now be minus y. Let this now be our equation 2. So let's substitute equation 1 into 2. It means anywhere we see y in equation 2, we replace it with 2x squared minus x minus x. So let's do the substitution. Changing y now will be equals to, let's expand this as we are doing that, to now be 2, we have square bracket. When we expand this, we have x squared plus 2x delta x plus delta x all square. We close the bracket, minus, we have our minus x plus delta x now, minus our y now is 2x squared minus x. That will be 2x squared minus x. Very important. Let's open the bracket. Changing y now will be equals to, let me multiply through by these 2. That will be 2x squared plus 2 times 2, that will be 4x delta x plus 2 delta x all square. Let this minus multiply, that will be minus x minus delta x now, minus 2x squared plus, minus times minus is positive, that will be x. Very important. Clearly here, 2x squared minus 2x squared will be 0. Very important. Then minus x plus x will still be 0. Then we're left with changing y now will now be equals to 4x delta x plus 2 delta x all square minus this delta x. That will be minus delta x. The next thing for us to do, let's divide through by delta x now, because we are trying to find change in y with respect to x. So let's divide through each term here by delta x. So delta y divided by delta x will now be equals to 4x delta x divided by delta x plus 2 delta x all squared divided by delta x minus delta x divided by delta x. Very important. So let's, therefore now, we divide through now. Therefore now, our delta x now, let's clean this. Therefore, delta y by delta x now will be equals to, let's reduce this. We have 4x plus delta x here 1. We have 2 delta x, 1 delta x will remove this, other delta x will remove this, will be left with 2 delta x now, minus delta x divided by delta x is 1. Very important. So, the limit now, as to get more accurate result, we have to set delta x to be 0. As delta x approaches 0, what will be the derivative of this function now? So the limit now, as delta x tends to 0, of this change in y with respect to change in x will be equals to, anywhere we see delta x, we substitute 0. So it will be 4x plus 2 into 0 minus 1. What are we going to have? This will be 4x minus 1. Very important. Then we conclude that hence change in y now with respect to change in x will be, we now say hence dy by dx now will be equals to 4x minus 1. So this is said to be the derivative of this function using first principle method. Very important. The reason why we are setting delta x to be 0, to get more accurate result, we have to, as delta x approaches 0, what will be the derivative of this function? Y equal to x squared minus x. Very important. So this is said to be the solution to this question. Thank you for watching. Please do share this to your learning colleagues, and don't forget to subscribe to TJ Smart Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. See you in my next video with example 3. Thank you for watching.